All right, good morning, 6th period and 7th period. We are at 3rd period right now. 3rd period, say hi. Hi. It is the morning, so we're speaking to you in the future. You're going to be with Miss Walken today, so she's going to be guiding you through these notes while you're going to be listening to my voice. Tomorrow's an important day because what lab is it, guys? Milky Way. So you need to know this information, and I'm not going to be here, so that way you can do the Milky Way lab tomorrow. If you have not brought a Milky Way by now, you need to. So what you're going to need is you're going to need the packet in front of you that's got a picture of the plate tectonic maps, and you're going to need your journal. So let's begin. So today we're talking about major geological events caused by plate tectonics. All right. If you can see on the map, plate tectonics are always moving. They're going to move towards each other, away, or side to side. So at this time, please start drawing the arrows that you see in red at the front of the board onto your paper. There's between the North American and the Pacific plate, they come together on both sides. The Australian plate, they come together. The Australian plate and the Antarctic on the bottom left is going to go away. The Pacific plate and the Antarctic plate go away from each other. If you see right where California is and the Pacific plate, they go side to side. The Nazca plate and the Pacific away. Gets a little hard to see here, so I'm not going to circle the ones in the center. Thank you, 3rd period, for being so quiet, so 6th period and 7th period could work. As we get to the right side of the North American plate, it goes away from the European plate, top and bottom. If you notice, the South American plate and the African plate are going away from each other, as well as the Antarctic plate. And the Europe plate and Indian plate together. However, the African plate and the Indian plate are going apart from each other. And the African plate is moving apart from the Arabian plate. So make sure you get the major ones there. Don't forget the South American plate and the Nazca plate. Sixth period and 7th period, it's raining right now. You could possibly hear the rain and the thunder. Third period, raise your hand if you need more time. 6th period, 7th period, we're going to give you one more minute to draw the arrows. Then we're going to move on. All right, let's do 30 more seconds. 3rd, 6th, and 7th period. All right, 10 more seconds. All right, guys. So you notice that there were about, show me with your fingers, how many direction of plate movements occur? How many? Yeah, I'm seeing a lot of threes here. There's 3 types. They either go towards each other, away from each other, or side to side. So, take out my pen. There we go. All right, so there's going to be 3 types of boundaries. Divergent, please write this and show the arrows into your journal. Divergent would be away from each other. The plates are moving apart. So divergent, draw the arrows, right plates are moving apart. Don't worry, this won't be a lot of notes today. And then converge. All right, converge, they come together. Draw the arrows, right plates come together. And transformation, which is my favorite, and I'll show you why in a little bit, are going to go side to side in opposite directions. So the plates slide horizontally past each other. So the parts in yellow need to be in your journal. At this time, Miss Malkin, you can pause this video and play the YouTube video I've made for my kids in the subnotes and the flash drive. And then you can start back up in a few minutes. Thanks. All right, so you just should have watched my YouTube video demonstrating divergent, convergent, and transformation boundaries. So we're going to come back to these signals, so make sure you remember them. That's my YouTube video page. All right, so divergent structures. Class, show me divergent. Divergent. Show me convergent. Divergent. I was trying to trick you there. All right, so what I was saying earlier is the magma is rising up and new crust is formed as these plates pull apart. So the land features I was talking about in my YouTube video was the mid-ocean ridge. Right, it's going to be the mid-Atlantic ridge is the underwater mountain ranges underneath the Atlantic Ocean. There's also rift valleys, all right, like the African Rift Valley. All right, they can pull apart and they can get a very, very deep, basically, hole into the ground. So magma doesn't need to come up every single time. All right, it can also cause earthquakes as well. All right, you don't need to write this down. All right. So in the Atlantic Ocean, which is between what 2 continents?
America and Africa.
All right, the North and South America, and then the African and Europe continents. Okay, there's going to be the largest, even larger than Mount Everest, all right, Mount Everest ocean ridge underneath the ocean, okay? So there's actually mountains taller than Mount Everest. They're just underneath our ocean. So what's happening, all right, is we're having divergent boundaries come apart. Show me divergent boundaries. The magma is coming up and cooling. Then it keeps separating, and it's cooling on top of that, and it's layering, 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 and layering. One day, we could actually have a whole bunch of islands, right, that are coming up between the Atlantic Ocean. So if you guys will look at the board there, you'll see, show you guys, right here, it's the world's largest mountain range. It happens to be underneath the water. Right here. So there's a whole bunch of mountains forming underneath our ocean. On the right-hand side, you guys, in this picture, you'll see this where the plate boundaries are. Notice how the plate boundaries are right on the mid-ocean ridge. Interesting, huh? Yeah. All right, so that's going to be where all the mountains are formed. So if you look down at the bottom, all right, this oceanic crust is spreading, and it's going out in a divergent way. All right, and then this magma is coming up, and it's constantly pushing back the crust, and constantly forming new crust. All right, so this is kind of this is a really good little video sort of clip of how divergent structures work. Okay, so if you see underneath, the magma is coming up. All right, it's cooling and making new rock, but then it's constantly pushing away. So here's the youngest rock right at the center as it pushes out to the older rock as it pushes down. Eventually, the rock that's way over, let me show you guys, that's way over here will eventually push back down, right, underneath the continental crust. I'm going to write CC for continental just because I don't have that much space. Will eventually subside, and what happens when rock gets into our inner core? It's going to melt, okay? So this is an example of sea floor spreading. Pretty easy. And it makes mid-ocean ridges. All right, so more mid-ocean ridges. So there's some in our Pacific Ocean, as you guys can see. Pacific Ocean, right here. So we've got some more underwater mountain ridges in the Pacific Ocean, which is right along the plate boundaries. And we also have some next to India over here and around Africa. So we've got a bunch of mid-ocean ridge. Take a look at your picture that you were labeling earlier. Do the pictures follow what you drew? Yeah, they should be going, these plates be going away or towards each other? Away. So in your picture, you should have made sure that these were going away. What kind of boundaries were these again? Huh? Divergent. Divergent. Excellent. All right, some divergent structures are not always found underneath the ocean. When they're found above the ocean, they can be rift valleys. All right, so rift valleys commonly are found in Africa, as you guys can see from the picture below. All right, they pull apart and they make these big trenches almost. All right, so they separate. They kind of look similar to the Grand Canyon, although don't get confused because that was not how the Grand Canyon was formed. Who knows how the Grand Canyon was formed when talking about rocks? Erosion. Erosion. Thank you, and weathering. Awesome. So this is going to be an example of our African Rift Valley. Also, water falls into the rift valleys in certain parts of Africa, so they make almost like a giant river. All right, so these are going to be found above land and not necessarily underneath the ocean. More divergent structures. So there's one that goes across Iceland. All right, there's also some mountains at those little points right there are going to be mountains that are close by. It's kind of hard to see, but underneath here on that bottom picture, that's going to be the Iceland Rift Valley. So like I said, it kind of looks like a canyon, like a Grand Canyon, but that's not how it was formed. All right, convergent boundaries. So the crust is destroyed and recycled back into the mantle. All right, so what happens here? Show me guys convergent. All right. Awesome. So as you converge, right, they rise up. Okay. All right. And it can be recycled back into the mantle. 3 types of convergent collisions. All right. So there's trenches, volcanic arcs. There's mountain ranges. This isn't going to be a land feature, but it can cause earthquakes. All right. So some volcanic arches are going to be like the Andes Mountains. All right. And the mountain ranges, such as the Himalayan mountains. Who knows where the Himalayan mountains are? Dylan. And where? They're kind of a big deal. Max?
Asia? Russia?
Huh? Asia? What's in Asia? When we're talking about mountains, that's a big deal. Joyce? Big deal when it comes to mountains.
Nepal.
Let's see if my... Yes, and what's in Nepal?
Mount Everest.
Huh? Mount Everest. Yes, thank you. All right. All right. So what happens, all right, as they converge together, although I showed you guys where your fingers lift up, show me where you put your fingers and lift up. All right, so this is when both plates are going to be continental and continental. So are they more dense or less dense than each other? Trick question. They're equal, so they're not going to sink underneath each other. All right, now let's put your right hand continental, your left hand subduction. Come together. Your left hand should be going underneath the continental. So this is what I'm talking about, how they recycle back into magma. So this is called subduction zone. It's a result of convergent boundaries when there's an oceanic and continental crust. So are mountain forms found here? Not necessarily. Okay, when they come together and they're both continental, like what I showed you at the beginning, That's how mountain ranges are forming. So the more dense plate slides under a less dense plate and sinks into the mantle. So that rock gets lower and lower and it remelts again. The features can include oceanic, so trenches, all right? The oceanic and continental, which is mountain ranges, all right, on the ocean. And then continental and continental can also form mountain ranges. All right, so some subduction examples. All right, so here, let's say this is California's coast on this one side. All right, here, I'll show y'all. All right. On the right side, sometimes it's a really nice, really nice smooth coast, right? And sometimes it has mountain ranges, so it depends how that subduction zone is coming together. All right, so this land feature, so this is going to be a trench right here that kind of looks like a really deep kind of V look. So it's going to be a really deep trench. And when I mean like really deep, that looks small, but I'm talking like very deep, like scary into the abyss deep. All right, the crust is going underneath the continental crust, and it's eventually going to melt back into what? Magma. Now, sometimes what happens is gases can get trapped in these subduction zones, and they get very hot, and they start to break apart, okay? And they come up, all right? And they come up and make underwater mountains that eventually come out of the water, all right, to make volcanoes. So we've got continental crust, and in the middle of our ocean, we have islands. Anything sound familiar here? Hawaii. Yes, okay. So these are we can have some islands, all right? So these subduction zones underneath can make islands, all right? And they can also make the continental crust and lithosphere go underneath. And all right, so subduction, the Morena Trench is a very, very, very deep, like 31,000, all right, 31,000 feet deep, all right? So when you're looking into something dark, it's scary down there, all right? And it is found close to the Philippines on this side. Let me show you guys with my marker. All right. And then the Morena Trench is going to be over here. So really deep, scary trenches in the ocean where we find all these super scary sea creatures. Marshall? You don't have your hand raised? Put your scissors away. You just got called out all my classes.
Okay.
All right. So then I was talking about Hawaii and how we get these volcanic arches. Okay, so these gases get stuck underneath these trenches, and the gas comes up and it breaks down with magma. So as you can see at that top left picture, all right, the magma comes up, the magma cools, right? It pushes down, the magma keeps coming up, pushes down until we got a super big volcanic island that's actually in the ocean but coming out of the water, similar to Hawaii. Hawaii is on the bottom left side. All right, so this can happen because of subduction zones. All right, the Caribbean plate and the North American plate are coming together to make these volcanic arches. All right, so when we have oceanic and continental crust, sometimes they make a really nice smooth beach. Sometimes they kind of converge a little bit upwards. All right, so as this oceanic crust, all right, subducts underneath because it's more dense, yes. This continental crust is going to stay on the outside, but sometimes it starts to kind of bend a little bit here. All right, so they start to bend, like you can show your hand. Your knuckles are going to be where they bend, and they can make mountain ranges. Not all the time, but sometimes. So typically on the west side of South America, there's going to be a mountain ridge that was caused by the oceanic and continental crusts coming together and pushing up these mountains, kind of like a bend in the Earth's crust. Can there be a smooth beach there? Yes. Can there be mountain ranges? Yes. So it all depends on how the Earth is moving. So either one can happen. Typically, though, it's going to be subduct underneath the other one. All right, so here's some pictures of volcanic mountains that were formed underneath the ocean through subduction. But as magma started rising from these trapped gases, came out of the water and formed their own islands. So we've got Hawaii and some other volcanic islands. Cool, huh? Yeah. All right, so convergent boundaries. All right, so they can come together. Remember when I showed you in the video, coming together and your fingers kind of came up? All right, that's from two continental crusts colliding. So are they the same density? Yep. Yeah, so when they're the same density like this, all right, they're going to bend towards each other. All right, and they're just going to start to kind of crush up. This is how we have some really high mountain ranges. All right. All right. All right, so it's the folded mountains. All right, so typically if you look at this picture of, there we go, this picture of our world, we see a lot of mountain ranges here. We see a lot here. We see many here. Look at your map. All right, notice that up here, I'm adding a few more. All right, notice your map and notice where the plate boundaries are. And look at this picture of our world and look where our mountain ranges are. Starting to see a little bit of connection here? So we have our major mountains, which are going to be along the east side right here of the Pacific Plate. Then we have, on this side, we have a lot of our really big mountains, right? Notice on the west side of our Pacific Plate. All right, the Himalayan mountains. What's happening here, okay? This is found in India. All right, the Himalayan mountains, you can see on this map right here. Get my pen up, sorry. All right. Where they're located. All right, so the India plate looks like this. What's happening here is the Eurasian plate and the Indian plate are colliding, and they're forming these Himalayan mountains. All right, so before this is what happens, and then when they start coming together more and more, they start rising. Are these mountains rising really fast? No, probably a couple inches per year. Not very fast at all. But then we got some major mountains here. All right, so some more convergent boundaries. The Andes Mountains. Y'all know where the Andes Mountains are? What continent? South America. Awesome. So we got the Andes Mountains here. So here's an example of oceanic and continental crust subducting, and it kind of starts to bend up, and there's going to be mountain ranges. So this is where the mountain ranges are located. All right, they're located right here. All right, that's from subduction zone. So you can see as these plate subducts, they're going to, converge, my bad, converge, guys. Converge, all right, they're going to make these Andes Mountains. All right, here's a picture of the Andes Mountain on the right. Very pretty. I want to go there one day. All right, so putting it all together, here's an example of all three things we have learned. All right, so right here, I'm going to ask you guys for, hold on, my email's popping up, so I can't use my pen on the top. All right, so right here we've got, these two plates going apart. What kind of boundary is that?
Divergent.
Say what?
Divergent.
Divergent. All right, right here we've got this Pacific, it's not necessarily Pacific, excuse me. We've got this continental crust here and this oceanic crust. What kind of boundary is that?
Convergent.
Huh?
Convergent.
Convergent. Yes, and what kind of convergent? It starts with an S? Subduction. Excellent. All right. What plate is this right here? Is it continental or oceanic?
Continental.
What plate is this right here? How can you tell? Because of the different
Density.
densities. Y'all are so smart. What is this plate right here going apart from each other?
Divergent.
Divergent. All right. And what are they creating? Underwater mountains known as mid-Atlantic ridges, or mid-ocean ridges. All right. This we've got some trapped gas here. All right, so we've got a hot spot, which can form underneath the crust plates. This is going to be how Hawaii was formed. And then, what boundary is this one?
Convergent.
Class, what boundary is this? Left-hand side. Convergent, and what's happening here?
Subduction.
Subduction, and the gas is being trapped, all right, and coming up to make a volcano. Excellent job. All right. Put my pen away. All right, so transform fault structures. So crust is neither destroyed nor created and can occur between two oceanic plate or oceanic continental plates. And these features include earthquakes or fault lines, like the San Andreas Fault. So this is the DJ one I was showing y'all, like that. Waka waka. All right, so what happens here? All right, for oceanic and oceanic, the land features can make a fault line. All right, so basically what happens when you're looking at this is it looks like, ooh, hold on a second, email again. All right, so it looks like there's a big, literally the oceanic crust has just moved from one side to the other. Okay, it looks like it's been picked up and moved. So if you'll see on this line right here, all right, there was a line, and because it moved, now it's on different places. All right, continental. All right, this is going to be a fault line. This is what fault lines look like. All right, this is the area view of the San Andreas Fault. Okay, and it occurred in 2007, I believe. All right, so it just moved from one to the other. Next. All right, the San Andreas Fault. So if you guys can see here on the left side, that's what it looks like today. It's going to be formed where San Francisco starts, all right, and goes all down California. It kind of breaks up California, not necessarily into two. You guys look at the picture on the right-hand side with the train. There was a train where the fault line was located. Look at the picture, bottom right. Right? And you can see as the boundary moved, it pulled the rail, pulled the rail and moved it from side to side. So you can see it makes a big S here. The top picture, a farmer on the right-hand side, that's going to be where they were planting plates, and because the fault moved, it moved. All right, take a look at your earthquakes picture in the packet that you got from the front. All right. So as you can notice, these are where all the earthquakes have taken place. So there's dot. What do you notice? It is similar to what?
The lines of
The plate boundary lines. Okay. So do we actually for certain always know every single theory on Earth? No, not necessarily. We do not. Okay, this is a theory. The plate tectonics is a theory. We can get very close to understanding plate tectonics because we see maps like this. We've charted earthquakes and we think there must be going something on with earthquakes. So as we start to study and we track these earthquakes, we can start to make a hypothesis that our plates are constantly moving, and here's where they're moving. So with earthquakes, typically they're moving from transformation boundaries. So if you look at your map, you will see that the transformation boundaries happen where it is really dark from your earthquakes. Make sure you're on the earthquake one and not the volcanoes one. All right. So our plate boundaries we can see here. All right, this is going to be where a lot of our earthquakes and a lot of our volcanoes happen. So if you guys see here, it's kind of hard to see here, but you can see the direction from the arrows. I'm going to show you guys some arrows here. All right. So this plate is moving down. All right. This plate is moving down as well. All right. While the other part is going in a different direction. All right, volcanoes. Look at your volcano map. My picture is not as good as yours. This is where we tracked all the volcanoes. All right, so again, theory of plate tectonics. We have never gone underneath plate tectonics, and we can't see them moving. But we believe they're moving because we can track these volcanoes, and we can see where magma is coming out. We can also see that gas is trapped, creating these volcanoes. So looking at your map, you can start to see all the different volcanoes and where they've been located. All right. So where do you see the most problems? If you were a geologist, where are the most problems in the world seem to be located with volcanoes and earthquakes? Where do y'all think, London?
Well,
There's a lot in North America. There's a lot in South America. I agree. William, where are some other locations?
There's a lot on the east coast of like Asia and.
Yes, y'all are understanding it. All right, who's heard of the phrase "the Ring of Fire"? Awesome. Third period's got a lot of hands up. All right, maybe Johnny Cash fans, 6th period and 7th period. I hope you have a lot of hands up. All right. All right, so this is what we call the Ring of Fire. We call the Pacific Plate the Ring of Fire because this is where the most earthquakes and volcanoes, all right, have been found and located. So it's kind of like a very dangerous place to live, which is really weird because a lot of celebrities choose to live in California. So it's called the Ring of Fire. All right, my husband, kind of a funny story. All right, my husband told me once, we were joking around about earthquakes, and I go, you haven't been in an earthquake. He was like, no, I was in a big earthquake. I was like, what? No. And he goes, don't you remember? I'm from Seattle. I was like, oh my gosh, you have been in an earthquake. So when I heard that story, I thought that was just really bizarre that there's actually people that we know, who knows people who live in California, Oregon, and Washington, that have experienced this. All right, he told me it wasn't a very big earthquake, but it was. All right, so if you can see all around this area, all right, this is called the Ring of Fire because it's very dangerous. All right, Ring of Fire because all right, magma can come up. All right, there's also a really famous Johnny Cash song talking about the Ring of Fire, just talking about dangers, all right, and being bad. Yeah, y'all got it. All right. So now, my 3rd period they helped me set this up, so they're not going to have as much time as my 6th period and 7th period. But for the rest of class, I'm going to pass out the picture vocab. You need to cut it and put it into your journal. There are scissors and glue in the back. You're going to wait for Miss Walken to give you a lab table. She's going to assign you lab table 1, 2, 3, 4, 5, or 6. Leave 7 because I've got some paperwork I need to take care of. Thank you guys. I'm sure you were excellent for your sub. 3rd period, give yourself a round of applause for being so awesome. All right, that's enough 3rd period. That's enough 3rd period. Thank y'all. All right. So please go back to lab stations. You have the rest of the class to cut and glue in your picture vocab. Make sure you're reading as you are cutting. Thank you, and I will see you guys tomorrow. Don't forget your Milky Way lab. Say bye.